Good morning, champs! Today we solve another three-point mapping problem. We want a Möbius transformation such that f of 0 equals 1, f of 1 equals 0, and f of infinity equals infinity. So now we are actually moving points around. Again, we start with the general form f of z equals az plus b divided by cz plus d. First, we use the condition for infinity. If infinity maps to infinity, then c must be 0. That simplifies the function to a linear function. So now we have f of z equals az plus b. Next, we use f of 0 equals 1. That tells us b equals 1. Now we use f of 1 equals 0. So a plus 1 equals 0, which means a equals minus 1. So the final function is f of z equals 1 minus z. This transformation swaps 0 and 1. It reflects the real line between those 2 points. This example shows that when infinity stays fixed, Möbius transformations reduce to simple linear functions. In the next video, we will move all 3 points and the transformation will become more interesting.